A little problem about a mathematical model. So, the temperature in degrees Celsius in a city on a particular day is modeled by the function t given by t of t equals 75t cubed minus 836t squared plus 3100t minus 4185 all over 14t squared plus 10t minus 35, where t is measured in hours from 12 p.m. for 2 less than or equal to t less than or equal to 9. So from 2 to 9, I believe that's going to be a.m. Based on the model, how many hours did it take the temperature to increase from 0 degrees Celsius to 5 degrees Celsius? So the plan is sketch the graph. We have a calculator for this problem. Find where it's 0, find where it's 5, and subtract those two x values. So actually, let me write that down. So the plan. Step 1, graph. Step 2, solve t of t equals 0 and t of t equals 5. And step 3, subtract those t values. So let's dive right into it. First, graph. Let me clear that out. So I'll do it the smart way. If I have it, may as well. 75, and I'll use an x here. 75x cubed minus 836 x squared plus 3100 x minus 4185. I'm going to double check these before I do anything else. 14x squared plus 10x minus 35. Let's make sure I didn't mess up. So the denominator looks good. 14x squared plus 10x minus 35. The numerator, 4185, 3100, 836, and 75. Okay. And I want to solve where the temperature is 0 and the temperature is 5. So I'm just going to graph 0 and 5. That way I can do intersections. Additionally, let me go to the window and say I don't care about all these values. I really care about times from 2 to 9. My input is my x value. My output is my y value. And I really care about temperatures from 0 to 5, so I guess negative 10 to 10 will work for that. And let's do a graph. Okay, I cross over 0 right here. I cross over 5 over there. And so I will intersect, since I already have them. It asks what the first curve is. That's my first curve, sure. It asks what the second curve is. I want to see where that equals 0, sure. And that looks awfully close to where it hits 0. And I do, in fact, hit 0 at 5.420253. So maybe I'll call it T0. Now let's find out where we hit 5. So calculate the intersection. This is still my first curve, but my second curve, I'm going to press up to change that to 5. My guess, I see it intersects over here, so let me go over to that point as close as I can get. It's not necessary, but it makes it a little quicker. And I get 7.7007238. Okay, I want to know how long it takes for this change to occur. And to do that, I just subtract these. So 7.700 minus 5.420. Go to my calculator. And I could, just press X and it gets that value for me. The problem with doing that is I actually had two values here, so I had to get rid of one of the x values to get this other one, and I could have stored the variables, but I'll just do this. So 7.700 minus 5.420, and I get 2.28, or D, 2.280.